Tonight, a special edition of Bang Goes the Theory to help you improve your brain.
We're going to drive our brains to their limit.
Engineer Jem trains his brain to drive a car using thought alone.
Oh, brake!
Biologist Liz unleashes her brain's full potential.
We did find a change in your brain. Yes!
We meet a man with an amazing story.
How can he function with just half a brain?
And we make scientific history, putting brain training games to the test. 6 months ago, we launched the world's biggest scientific experiment ever to find out if brain training games really can improve your brain. So, can you train your brain? Tonight is all about brain power. Now, thousands of you took part in our amazing brain training experiment, and tonight we're going to be giving you the results.
We certainly are. Now, we've got 100 of those brain trainers right here in our studio. Hello. Thanks for joining us. They look happy, and for them, the training isn't quite over, because with their help, we'll be showing you how to release the untapped potential of your brain.
Tonight, we're going to be testing a whole range of techniques to find out how we can improve our brain function.
I have no idea what this has got to do with brain training. Well, if it does increase my brain power, I might do it more often.
Okay, good stuff. But let's get down to business. Big business, in fact, because brain training has become $1 billion industry. Computer games to improve your brain really are the latest craze. Chances are you'll know somebody who's bought one of these. In fact, the UK's most popular video game ever, believe it or not, is a brain training game. And over 3 million of us have bought this one. Now, games like these make some pretty impressive claims. Playing games can make you smarter, improve your memory, and even improve your general brain power. But here's the rub. When you actually look for hard evidence of these claims, by that I mean proper trials published in scientific journals, the evidence for people like you and me is pretty thin. So we decided to take matters into our own hands.
Now, 6 months ago, right here on Bang, we launched an experiment to find out if brain training games really do improve our overall mental abilities.
Over 13,000 of you logged on to the Lab UK website to play our brain training games, making it the world's biggest brain training experiment ever. And then we tested to see if the games had any effect on your brain's performance.
Now, we teamed up with some of the country's leading academics, researchers from the Alzheimer's Society and from the Medical Research Council. And together, we devised a scientifically rigorous experiment to answer the big question. Does brain training actually work? Can playing a set of games make your brain better at doing other things?
OK, now we're going to be giving you the results a little later in the show, and I have to say they're pretty conclusive. But first, let's just have a look at what our brains are actually capable of. Here at Bang, we set our resident engineer Jem a bit of a challenge. This time, we're going to push his vast brain to the limit.
I'm not sure my brain power is vast, but I'm going to put it to the test by attempting something ludicrously difficult. Something that has never, ever been successfully done before. I'm going to try to drive a taxi with the power of thought alone. So my challenge is to somehow get a completely driverless vehicle over here, remotely controlled by a human brain over here. Now, the way I imagine this happening is I know a human brain produces different electrical activity for different thoughts. And I know that almost any electrical signal can be detected. So I'm bringing Dallas.
How's your brain feeling?
To try out something that claims to read your thoughts. This headset picks up the patterns of electrical activity in your brain. It connects to a computer which uses these thought patterns to move a virtual cube on the screen.
That's proper sci-fi.
If I can train my brain to use this, maybe I can use it to control my taxi.
would you like to try it out?
Yes.
So would you like to...
First, we have to set the cube to recognise the pattern of activity of a specific thought.
Whatever we choose our thoughts to be, they have to produce consistent electrical signals in the brain, one that's repeatable. Otherwise, the computer has no idea what we're trying to do. So it's getting that constant electrical signal, the one that's the same every single time.
Are you ready? 3, 2, 1, go.
So for forwards, I imagine pushing a boulder.
Yes. Dallas.
The force is strong.
Very good.
Right out there.
For me, I think of pushing an accelerator pedal and think panic to stop.
Wow, that's good. You're good. You can hold it right there.
That's impressive.
Oh, look at that! Pulled it right off the screen.
OK, so it looks like we can move a cube around a screen. But we want to control a 2-ton taxi. We thought it might be safer to start smaller.
Ooh, I want to be that one.
OK.
The computer guys have linked our headsets up to 2 toy cars for a race of mind against mind, car against car.
What we've done for you is linked a radio-controlled car to your brain headset.
As well as the computer program moving a cube on the screen, it now sends an electrical signal out of the back of the computer and into the remote control unit. If I've managed to train my brain to think push clearly enough, the car will follow. But are our brains up to the challenge?
On your marks, get set, go.
I'm desperately trying to think forwards, but the cube and car have other ideas. Meanwhile, Jem pushes his mental accelerator and shoots off down the room. Under pressure, focusing on the right thought is incredibly difficult.
Hey!
Even for Jem.
Push, push, go on! The reason why this is so difficult is because I've got to hold just one thought in my head, so that certain areas of my brain have electrical activity and others don't. And then that single thought has to be the one that controls the taxi. No.
Clearly, our brains are going to need a lot more training.
Oh, he's spun! He's spun!
Because so far, our brains just don't quite seem to be up to the job.
There now appear to be 4 minds in this competition. Mine, Dallas's, and both those cars have a mind of their own. We don't stand a chance at this stage. Dallas, focus.
Oh, Jem, it's not looking good. How come the cube was working out well with the cars? You're thinking forward, the car's going backwards.
What happened was a huge extra level of complexity. And the whole system is designed to work by shifting a graphic around, but trying to take that into the real world was a bit difficult.
Do you think he was any good?
No, not really.
Oh, you're going to have to do better than that, Jem.
Okay, and given what you've seen so far, how do you rate my chances of being able to radio control a full-size taxi and then mind control it?
Go on, a real taxi. Do you think he can do it?
No chance.
Every faith in you. We have
Thanks
every
for the
faith
confidence.
in you, clearly.
Anybody else with a different view?
Anybody feeling a bit positive about this whole outcome?
I think things can only improve.
See, I'm liking this lady.
Now, the idea of getting more out of our brain is obviously appealing, but how much is it really possible for us to change the way our brain works? Now, our brains are absolutely amazing, and obviously our brain's not that big, unless, of course, you're Dr. Yan, but it is one of the most complex things in the entire universe. It's got as many brain cells as there are stars in our galaxy, over 100 billion, and each one of those 100 billion brain cells connects with up to 10,000 other neurons. And it's these billions and billions of connections that generate all our actions, our thoughts, and our memories. The way our brain performs depends upon an incredible, vast network of connections between brain cells. And the more connections, the better the brain works.
And what's even more fascinating is that these connections aren't necessarily fixed. Scientists have recently discovered that the brain has an incredible capacity for change. A pioneering and frankly extraordinary operation has demonstrated just what the brain is capable of. And the story of this little boy will show you how.
At the age of 3, Phil Daffin started having uncontrollable brain seizures.
He was dreadful, absolutely dreadful. He was having seizure after seizure after seizure.
Within 2 months, he was having over 200 fits a day.
His seizures were pretty resistant to the medication. He had almost continuous twitching down the right side of his body, going in and out of seizures, despite what we tried medically.
Phil was diagnosed with Rasmussen's encephalitis, a rare progressive brain disease that attacks and kills brain cells on one side of the brain. His parents were told his only hope was to have a radical operation, unthinkable to any parent. The doctors felt there was only one option: to disconnect half his brain.
He was so ill, there wasn't another decision to be made. It was that or let him die. He wouldn't have lived for much longer because your body can't endure that many seizures in one day.
On the 13th of January 1993, Phil went into the operating theatre.
We disconnected the whole of the left side of the brain. The key functions that we'd be concerned about would be movement down the right side, which would be here, otherwise sensation down the right side of the body, vision on the right side, which would be governed at the back of the brain, the language cortex, and we also disconnected that, which is more apparent on this scan. You can see this is the left side where most of the brain tissue has gone, and this is the right side, which looks normal.
It is a big black hole on the left-hand side of his head. That's incredible. I can't actually imagine somebody could survive surgery like this.
Phil is now 21, and he's come to London to meet one of the doctors who played a seminal role in the life-saving operation. But first, he's agreed to meet me.
So what's the first thing you remember after waking up from the operation?
The first thing I said was I wanted a piece of toast. And believe you me, I enjoyed it.
Oh my gosh, and that was only a couple of hours after the operation.
I know, but all the nurses and the doctors couldn't believe it. So they just could not believe it. I don't know who was more surprised, me or them, to be honest.
Just hours after the operation, Phil was awake and talking. But what was even more extraordinary was what came next. Phil's right hemisphere trained itself to take on most of the work that a complete brain normally handles.
When I had my surgery, I lost the use of my legs and my hands as well. And I've had to relearn all of that again.
It took 18 months of hard physio and language therapy to relearn how to walk fully and regain all of his language ability.
What is truly incredible for Philip is that despite the illness he went through at 3 and the operation he went through, he is able to grow up, develop with normal intelligence, normal mathematical ability and normal language function with the training and determination that he and his family have shown.
Somehow, Phil's remaining hemisphere seems to have trained itself to do pretty much all of the work of a full brain.
Hi, Phil.
Hiya.
Nice to see you.
Yeah, it's nice to see you.
To find out how, Phil's come to see his neuroscientist, Professor Varga Kadem. She's been looking at how he manages to speak without the specialist language area that most people use, known as Broca's area.
And this area here becomes active when the person is thinking of words.
Phil's normal speech area was removed in his operation, yet his remaining brain has compensated for this.
But this is the good side of your brain, the right side, and of course it's showing activation in exactly the same spot as the healthy controls, except that theirs is on the left side, but instead the right side is active.
Incredibly, Phil's right hemisphere trained itself to take over language as well as most of the other functions of the areas that were disconnected.
You see that?
Yeah.
Isn't that cool?
Yeah, it's really interesting.
You'd never seen that before, huh?
No, and that is really, really interesting.
This is the first time Phil has ever seen a scan of his brain.
I've never had anything so clear to me because I've just had what people have told me. And now I've actually seen it on the computer and it's there in black and white. it amazes me how my brain has like readapted itself, and now I can do everything that everybody else can do.
We are so proud of Phil that you can't put into words. He is an absolute walking miracle, and there's no other words to say, but he's a miracle.
Amazing.
Wow, that is an incredible story, isn't it?
It really is.
I mean, here's the amazing thing, though, is that Philip's half brain has managed to rewire itself almost into a whole, fully functioning brain. It's
Absolutely,
extraordinary.
and doctors think that the change of the speech area from the left side to the right side actually happened before the operation. So the left hemisphere was so damaged from the seizures that the brain was like, right, we need to recruit new cells on the right side for Phil to continue to speak. And then the rest of the connections were made after the operation so he could talk, walk, etc.
Yeah, well, that makes sense, because you think about a child's brain, a young brain, it's obviously going to be a lot more flexible than an adult brain. But how flexible do you think is an adult brain?
Well, adult brains are surprisingly still very flexible. Your brain and my brain can actually change quite a lot. In fact, our brains are constantly forming new connections. The question is, can we tap into that? Can we encourage the growth of new connections by doing things like brain training? Well, new research is showing that setting your brain some challenging tasks could well change it. And it all started with some of the best brains in London. London's cabbies are famous for having one of the world's most demanding training courses. Black cab drivers spend years learning the entire map of London on a moped to pass the knowledge. It's so mentally challenging that a few years ago, scientists took a look inside the brain of the humble cabbie. Thank you very much. What they discovered caused quite a scientific sensation. Now, the area of the brain involved in spatial memory and navigation is called the posterior hippocampus. And scientists showed that in cabbies, this area is 5.5% bigger than yours or mine. So are you guys aware of this research that's been done that shows that cabbies have a bigger hippocampus than the rest of us?
What?
Yeah, I know, exactly.
Oh, I know where the hippocampus is.
The hippocampus is kind of at the centre of your brain underneath the cerebral cortex near the end, and the bit in your brain that's bigger is the posterior part. The back part of your hippocampus has gotten bigger, has changed structurally, and is 5.5% bigger than the rest of us. Isn't that amazing?
What we want to know is, when you're going to do research into why they've all got bigger mouths.
Scientists think that cabbies' spatial areas may be bigger because they've got more connections. But is it their training that's caused this?
Now, without scanning cab drivers' brains before and after the knowledge, we can't definitely say that a change has taken place. I mean, it could be that the driver was born with a bigger hippocampus and was drawn to this job because he's naturally good at it.
But there is an experiment underway to see if simply training on a task really can increase the density of connections in the brain, something that might lead to a cabbie's larger hippocampus. And Dr. Heidi Johansenberg has said I can take part.
Hey Liz, how are you doing?
Grand, thank you.
First of all, she scans my brain to record what state it's in before I start training.
Okay, we're nearly done now, just another couple of scans to go. Are you still comfortable?
Now, the task that Heidi is going to give me involves complex bimanual arm movements, grasping and visual tracking in the periphery. That's juggling to you and me. But why juggling?
It does drive an awful lot of different brain areas. It's a very complicated task. It requires you to keep track of watching these balls and also move your arms in relation to them.
Right, here we go. It's a squash court.
For my first lesson, I've come to the Oxford University Juggling Club.
Basically, just get one ball and just practices just throwing it from hand to hand.
God, I'm going to be rubbish at this, I know already.
Throw it by your stomach and catch on the outside.
One, then the other.
One, then the next one.
I think some people are just naturally better at this than others.
I've got 6 weeks to learn a 3-ball cascade, so I've got to practice at home every day.
The problem is, the progress isn't happening fast enough, and I definitely don't have a good natural style to this. The way I'm getting on with this, I just don't think there's going to be any result on my brain scan. I don't think my brain is engaging in this activity whatsoever. So, I've been juggling, if you can call it that, for about 6 weeks now. And the truth of the matter is, I'm still absolutely rubbish. I have absolutely no natural talent for it whatsoever. But I'm about to get my brain scanned to see if it's made any difference. And the big question is, can practicing like this actually change the physical structure of my brain? Hiya, how are you doing? Good to see you again.
The MRI scans my brain again, and what we want to know is, will there have been any changes in any of the areas of my brain involved in juggling?
OK, Liz, we're all done. We'll just come and get you out.
Okay, thanks.
A few hours later, and it was time for my results.
So, how did you get on with the juggling?
It's not my forte, I have to be honest with you. I found it really hard, and I'm still not throwing them properly, so it was a bit of a struggle to juggle.
Yeah, and how are you feeling about seeing the big results?
I'm actually really excited. It's like getting an exam result, seriously. I want to do you proud. So show me.
So do you see what happens?
Yeah.
So the good news is we did find a change in your brain.
Yes!
So we found an increase in that area which is important for reaching and grasping to objects moving in peripheral space.
Okay.
So it makes sense for juggling.
Absolutely, right.
And what we saw, as you can see on the graph, is an increase, about a 2.5% increase in grey matter density of that area.
Is that pretty good going,
so
then?
That's pretty good going. That's pretty, on par with...
One of the most likely explanations for this change is that I've grown more connections in the area I've been using to juggle.
How does that result in being better at something else?
Well, the thought is that those physical changes will affect the way the cells work. So they might affect the speed at which impulses can be fired, how efficiently impulses can be transmitted between cells. So that would basically make the area work better. Then that has a knock-on effect for your behaviour.
So this pretty much confirms that training can actually change the physical structure of your brain?
Yep.
Amazing. Can I get a print out of this so I can show the boys? Thank you very much, boys, for showing off. Now, if training on a task like juggling, even if you're as rubbish as I am, can actually change your brain, can brain training do the same?
Well, whilst our studio audience have been busy playing brain training games, we've been peering inside their brains to see what's going on.
Sandra and Janet aren't wearing hairnets. These things detect the electrical activity in their brain. You're doing pretty well. Now, Jo here, she's having her brain tested sort of in a functional way. We're using infrared spectroscopy, is that right, Claire?
Near infrared.
Near infrared spectroscopy. And that sort of detects the blood flow in the brain and sees how much energy the brain requires when doing a task like this.
So, when Jo starts playing a brain training game, let's see what happens.
Claire, is it going okay?
Yeah, we're seeing a significant increase in the oxygen levels in Jo's brain as she's processing the maths task.
So this is when she was resting?
This is when she's resting, and this is when she started her maths processing, her brain training.
So Jo's brain may be more active whilst brain training, but will this have any long-term effect, like the juggling did? Will it stimulate the growth of new connections? Will it improve her mental abilities?
And that's what our experiment was trying to find out. Can exercising your brain with brain training actually make it better? Now, there's a huge number of brain training games out there that say they can improve your memory or increase your brain power. Well, we wanted to test that, so we devised our own games and got thousands of you to play them online.
And we devised our games with the help of Dr. Adrian Owen from the Medical Research Council. Great to see you again. Thank you so much for joining us.
My pleasure.
First question is, how do our games compare with the video games on the market? Are they representative of the kind of games most people play?
They are. I mean, we had two priorities with this experiment. The first was to try and include as many games as we could that are currently used in commercially available brain trainers.
Good stuff.
The second thing was to try and give the whole brain a complete cognitive workout.
Liking the sound of that. We devised a whole load of games involving skills like problem solving that exercise the frontal lobes, memory that stretch the temporal lobes, and maths that use the parietal lobes. And to be sure it was the games that made a difference and not simply using a computer, we also included a control group.
In our experiment, the control group were encouraged to use the internet for the same amount of time every week, but they didn't have any formal brain training, so we can rule that out as a confound.
Excellent, and that's when we asked you for your help. We asked all of you at home from 18 to 100 to log onto our website and play the games every other day for 6 weeks. Now, I've got lovely Emily here, who was definitely a bit of a fan, weren't you?
Yes, I did my 10 minutes of training every day and a lot more as well because I enjoyed it and I got quite hooked on it.
And after, a couple of weeks of doing it, did you feel any different? What were you thinking about the games and what they were doing to your brain?
Well, my scores have been consistently improving, which has obviously been a good sign, and I think my memory has improved as well.
Do you? Well, that's interesting. Thank you very much.
Emily and thousands of you across the nation stretched your brains for 6 weeks. Now is the time for the first lot of results. Did it have any effect?
But let's see what the results say for all 13,000 of you who took part. Now, the first thing we looked at was whether you got any better at playing the games themselves. We looked at your average scores across all games when you started off. Take a look at this. It's a beautiful thing. That's where you started off before the 6 weeks. After the 6 weeks of regular playing, here is where you got to. Take a look.
Let's see how good you got at just the games themselves.
Our audience are happy. That's a whopping improvement of 33%. Not too shabby.
Not surprisingly, playing brain training games makes you better at brain training games. But how useful is this?
To help answer that question, we'll be seeing one of the world champions at brain training games in action tonight. But before we get his opinion, we thought we'd see how our studio audience compared. For the last few hours, our brain trainers in the audience have all been playing at this game here. Now, what do you have to do in this game?
You get 5 numbers flash up for about half a second, and then you have to click on the boxes in order of the number sequence.
And is it easy?
It's very difficult.
Okay. Well, I can reveal that on average in the studio audience here, they managed a score of 30%. Not bad. But the world champion, well, his score beats yours hands down. It's 88%. Pretty good? Yeah? Okay. Do you want to see how he does it?
Yes.
Have a look at the big screen up there. He doesn't appear to find it that difficult. Meet Ayumu the chimp. Yes, he is very, very good at brain training games, but you wouldn't describe him as an intellectual giant.
Whoever you are, human or chimp, practicing at something will make you better at it. But just being good at the games doesn't mean you've got any cleverer. The only way to find out if brain training improves your overall performance is to test your general cognitive abilities before and after brain training. So that's what our scientists did.
In terms of what you've been doing, how have you found out whether or not these games are making us smarter?
Well, we looked at many different cognitive functions. So, for example, we looked at problem solving. Does problem solving improve after you've been brain training for 6 weeks? We also looked at whether people can remember longer sequences of digits, because that's obviously something that you have to do every day when you're remembering a telephone number.
And also, those are everyday things like memory, things like logic. These are very, very everyday things that we use.
Exactly. They're core cognitive functions that we use in everyday life.
So we tested everybody's memory and problem solving before and after brain training. Would 6 weeks of brain training make any difference to their everyday mental abilities? Well, what does the audience think?
Overall, I think the brain training will have increased our brain functions, our memories, and I think it will have worked.
I think there can have been improvements.
I thought it made me better at the particular games I was practicing, up to a sort of plateau level. I don't feel convinced that made any difference to the way my brain works normally.
I'd like to think that brain training does work.
I think the result is going to be that it improved our brains.
So we've heard from a few of you there, but what about everyone else? If you think your brain has been improved by the game in some way, I'd like you to hold up the blue light, so blue is positive. If you think that the games haven't improved your brain at all, it's still exactly the same, then I want you to hold up the red light. So after 3, are we ready? 3, 2, 1, hold up your light. Ah, okay, definitely blue, definitely blue. More of you think that your brain is working better because of these games. Very interesting.
So, you guys generally think that the brain training has improved your brains?
Yes.
Okay, who's keen to find out what the scientific results of this study were?
Yes.
Me too. Liz?
Okay, it's time for the moment of truth. Now, we already know brain training games make you better at those games, but do they improve your brain power, like some of the commercial games imply? Thank you to all of you in our studio and at home who took part. We could not have done this without you. First up, let's look at the control group that did no brain training at all, but they did spend time on the computer searching the internet. Now, our scoreboard represents roughly the range of scores for all our participants. Let's look at their mental ability at the beginning of the 6 weeks. This is how they scored on our tests of memory and problem solving. There it goes. Excellent. So that's the score they got before the 6 weeks. Average score of 4.6. And this is how the control group did after the 6 weeks.
Now, in theory, there shouldn't be much difference.
There we go. Ooh, right. Our test gave them a score of 4.8. So not much of a change there. Remember, that's the result of our control group. So far, so good. But now for the interesting bit. Does brain training have any effect on your overall mental abilities? Brain trainers, let's see how you did before brain training, shall we? There it goes. Our tests of memory and problem solving gave you an average score of 4.6. Exactly the same as our control group. But how did you score afterwards? Did brain training make any difference? 6 weeks, remember, of brain training, thousands of you across the nation. Did you do any better than our control group? Are you ready to find out? Let's find out. Ooh. Where's it gonna stop? Ooh. That's almost the same as our control group. Can you believe it? Our test gave you, our brain trainers, an average score of 4.9. Are you shocked and horrified? How are you feeling about this? Yeah. Adrian, can I ask you to join me? I am frankly quite surprised by the results. Okay, so we've got 4.8 from our control group, 4.9 from our brain trainers. So it's 0.1 of a difference. Does that mean anything?
Well, unfortunately, when we do the direct comparison between the brain trainers and the controls, the difference is statistically completely meaningless. There is no difference between them.
Okay, but what about the difference between the brain trainers pre and the brain trainers post-training? So you've got 4.6 to 4.9. Does that mean anything?
I'm afraid I'm going to have to disappoint you again, Liz. That difference is so small, again, it's statistically not meaningful.
Can we actually say that brain training games don't work?
The result is crystal clear. Brain training is only as good as spending 6 weeks using the internet. There was no meaningful difference between the two groups.
Pretty surprising stuff, I'm sure you'll agree. Adrian, thank you so much for joining us, and thanks for all your help with this.
For full details of the results and to find out why we want people 60 and over to keep training, go to bbc.co.uk/labuk. But what do our brain trainers here make of it all?
Well, rather disappointing, really. I was just hoping I could really improve my brain with that. I'm going to obviously have to find another way now.
Really gutted. I genuinely thought it was going to help, and it obviously hasn't, so I'm very disappointed.
I was really surprised because I think I wanted to believe that it improves my brain.
Pleasantly surprised.
Why?
I just kind of hoped that we could prove that all this money that people spend on these games is wasted.
So if our brain training games don't do much for your brain, what does this mean for the games we buy off the shelf, like the market leader Dr. Kawashima's brain training? Now, in their booklet, Dr. Kawashima claims that training the brain can help boost your memory, and certainly the website implies that this would transfer to everyday things. But our results clearly suggest that games like these don't improve memory for everyday things. So what does Nintendo have to say? We invited them to take part in an interview here today, and they sent us this reply. Jem, what did Nintendo say?
This is Nintendo's response, and I quote: "The challenges in Dr. Kawashima's brain training are inspired by exercises developed by respected neuroscientist Dr. Kawashima, who believes that the brain needs exercise in the same way that our bodies need exercise to stay in shape. It is like a workout for the brain, and the challenges in the game can help stimulate the player's brain. Nintendo does not make any claims that Dr. Kawashima's brain training or more brain training are scientifically proven to improve cognitive function.
It's a good job they don't, because our tests suggest there is no evidence they improve cognitive function.
Big question is, who's going to tell the chimp?
So if brain training games aren't the answer, then what is? Coming up, we've got a whole range of things to boost your brain's performance temporarily, and something that could really improve your memory long term.
2, 1, stop!
But for now, it's back to my and Dallas's attempt to train our brains to control a 2-ton London taxi through thought alone. Something no brain training game has ever been rash enough to promise. We started small, trying to control toy cars with headsets that read the electrical activity in your brain.
Thomas, focus.
And it was a disaster.
He spun! He spun!
So, while Dallas trains his brain at home with the headset...
You see, I can do it when I'm on my own, and I'm relaxed, and everything's going well. It seems to work fine.
I'm going to exercise my brain with some serious problem solving. How to remote control a full-size taxi. Now, driving a car when you're in it is difficult enough. The pedals, steering wheel and gears all need to be operated simultaneously. First problem is to find a way to work all these with some kind of crude driving robot.
Let's see how that works.
First up, acceleration. This is going to involve some lateral thinking and a bit of car cannibalisation.
This is the motor from an electric window winder unit. So we put a bit of voltage to here, and that goes forwards and backwards. Now, by attaching a rod onto there, and the rod down onto the accelerator pedal, we can use the voltage to here to move the accelerator pedal. The problem we've got is we've got to somehow get that voltage from a mind control unit. But this is the first stage in the plan.
Yes, it might look a bit Heath Robinson, but this is a lot more fun than a brain training game. Next problem to exercise my grey matter is steering. I'm hoping this drill is going to do the job.
Okay, now to find out if this actually works, I'm going to turn on the car to get the power steering running. So a little bit left, a little bit right.
I also fit a mechanical drive for the gears and a pneumatic ram for the brakes, and connect all these to a standard remote control unit. Now for the next test. Can I control brakes, steering, acceleration and gears simultaneously to replicate the subtle control of the human driver? Now, what I don't want to do is cause damage to myself or any of the buildings or any of the vehicles. Now, the most important thing is myself, so I'm going to climb in here. How this vehicle actually goes, I really have no idea. In theory, I should be able to control it remotely with this. In practice, we'll find out. I've got the mental abilities to weld it all together, but will it actually work? That's going, it's turning. Technically, it seems to work perfectly. I'm going to give it a tiny bit more throttle as I come out the turn. But trying to control it all with a radio-controlled joystick is surprisingly difficult. So nerve-wracking. Speeding up a bit now. Like I said, it's a bit difficult. Got to imagine you're in the driving seat. I am going slowly, and that's for a reason that I simply don't want to brake anything at this stage. But I'm quite... back off, back off, back off. Steer. Hand control is possible with this thing, but it requires a vast amount of thinking just to operate it as it should be. I've got a feeling that when we switch to mind control, it could actually fry a person's brain.
Ooh, Gemma's going to need a serious amount of brain power to pull that one off. But for the rest of us mere mortals, is there anything we can do to boost our brain power? If anyone has an answer for that, it's Dr. Jan. He's been trawling through the science and is determined to make our origins brighter by the end of the show. Isn't that right?
Absolutely. Trying as hard as I can.
Then?
Well, I've looked at a number of things. Diet, reading,
Yeah.
exercise?
Yeah.
Or how about a little intellectually stimulating music?
Ooh.
You might have heard of the Mozart effect, that listening to Mozart can somehow make you smarter. But is it true? I've come to the Royal Opera House in Covent Garden to try it out.
Oh, hello.
Thank you very much for volunteering.
Pleasure, I love science.
Have you heard of the Mozart effect?
Yes, I have.
Are you interested in finding out whether music affects your brain abilities, basically?
Obviously now, yeah.
Yeah, well... First of all, we give our volunteers a range of cognitive tests: spatial ability, memory, and reaction time. Then I've got to get people to listen to some music. And to make sure that they aren't distracted by any of this background noise, I've borrowed this. Now's the time to enter the pod. Thank you very much. Bye. The idea of the Mozart effect was based on experiments done in the 1990s. Researchers found that listening to Mozart improved people's scores at spatial IQ tests. And it's not just humans. Rats also seem to get smarter when listening to Mozart. But will our guinea pigs? The theory is that Mozart's complex melodic structures trigger patterns of brain activity used for processing spatial information, so that Mozart primes the brain to do well at spatial tasks. But to see if Mozart really is so special, I'm also going to try something a bit different. And for a fair comparison, I'm going to compare both to the sound of silence. Right, 5 minutes in the pod, time to put theory to the test. Now I'm testing them again with new puzzles to see what difference it's made. Are you ready? Yeah. Go.
This could be good fun.
Yeah, we've got some sellotape.
Big red spindle.
Orange.
Yep.
There's a flower there.
I mean, that can go there, and that can go there. Oh, damn. What's that?
Fantastic.
Could be here all day, you realise this?
Making an absolute pig zoo of this on national telly.
Penknife, cinnamon, ball.
There's something wrong here, isn't there?
No, I'm struggling with this, I really am.
Oh my God, I'm really thick, I can't do it.
Even if I move everything, that's not going to fit, is it?
A mug. And that's about it. I can't remember anymore.
I've got a memory like a sieve.
No.
Oh, very good. Very good, very good. That's 1 minute and 11 seconds.
Oh, it's as good as it's going to get, isn't it?
That's kind of a duck. With a hat on.
Squish it all in.
A duck with a hat. Thank you.
Time to see how our Mozart listeners did. So Scott, you had Mozart, didn't you?
Yeah,
So how do you think you did?
Yeah, I found it a little easier.
You remembered 5 on the first time round, 7 on the second. So Dan, you listened to Mozart, didn't you? Yeah. And you did a lot better at the spatial test. Do you think the music made a difference?
I might have done. I mean, I did the second puzzle pretty quick.
It didn't feel like you just had silence. Yeah. And you had Mozart. And on the memory test, well, you did a little bit better. You did a little bit worse. Researchers found that, on the whole, people listening to Mozart improve more than people listening to just silence. Since the original study in 1993, lots of other studies have shown the same sort of thing. But before we get carried away, how about our rock music? You listened to rock music?
I did, it was good.
It wasn't too loud?
No, could have been louder.
And how do you think you did on the test?
I think I might have done a little bit better.
You did, actually?
Because I felt a bit more alert after listening to the music.
Your ruler test was a little bit better. Your tangram speed improved even more than that, actually. You had 1 minute 10 seconds, and it was 35 seconds the second time round you did it. When scientists looked at other types of music, they discovered that there's nothing special about Mozart. Rock music can be equally mentally stimulating. Mozart's melodic structure doesn't stimulate our brain in any unique way after all. Any arousing music can improve your brain's performance. Listening to upbeat, enjoyable music stimulates the release of certain neurotransmitters. They're chemicals that pass information between brain cells, and these temporarily enhance particular connections in your brain. That makes it more effective at processing all sorts of information. And all that means that you get temporarily smarter.
Interesting stuff there, Jan. So does this mean we should all listen to loud rock music while we work?
Oh, no, it's not while you work.
Okay.
The interesting thing is that the studies have looked at before you start work, and it turns out that anything stimulating, like listening to exhilarating music, can give you that quick boost.
Ah, OK. So for all you parents at home, your kids are allowed to listen to loud rock music before they study, but then you can make them switch it off. Excellent.
So, if arousing music can stimulate your brain and help its connections to work better, is there a way we can directly boost these electrical connections between our brain cells and improve the working of the brain? Well, the latest research has come up with what seems like an unusual solution.
Do I need to worry about this? There's a bad smell of burning already, lingering.
Don't be concerned. This isn't one of my contraptions.
Okay, good.
This is transcranial direct current stimulation.
My favourite kind of stimulation.
That's damp sponges and electricity to the head, if you're a layman. Okay. The idea is that with carefully controlled electrical stimulation directly to his head, it should improve his memory.
Should. I think we're going to have to crank this up to 11. So can I just say, this isn't the same as like electroshock therapy. This is.
No.
I'm not going to sort of fry.
No,
Okay,
this is
good.
a very, very tiny current. It's about 10,000th of what you use at home to light a light bulb.
Okay.
So there's no dangerous shocks.
If we get this right, we should be able to improve Dallas's memory. If we get it wrong, we may fry him. No, that is not the case. As Charlotte said, it's milliamps we're talking.
Okay.
This morning, we tested Dallas's memory, and it's fair to say he was a little bit rubbish. He only remembered 11 items on the conveyor belt.
Cuddly toy.
Yes!
Remember that.
We are now going to directly stimulate his brain with electricity and see if he can improve on that.
I've just turned it on. You might feel a slight itching under the electrode.
Okay, I'm ready. Is there any smoke coming from my head?
No smoke.
Okay.
In which case, the time starts now.
Okay. Tennis rackets. Clock radio.
With a new set of objects, how many can Dallas remember whilst his brain is plugged into the mains?
Bowl, loo roll. Chip chop. Oh my god. Banana, drink can. Oh, blimey.
Okay.
Pepper pot.
That's
Okay.
all your items now, Dallas.
Okay. Oh, I can't remember any of them. I'm worrying about my itchy scalp.
Turn it up a bit, Charlotte.
Don't let Jim anywhere near it. Okay.
Now, Dallas.
Okay.
Your brain has had extra electrical stimulation.
Okay.
What were those objects?
Banana, thermos flask, there was a pot, there was a loo roll, there was a chip pan, there was a cuddly toy, there was a chicken, there was a tennis racket, there was a little clock radio, there was a cuddly toy, there was a... turn it up. There was a plant. There was one of those nice a pot plant, a sink plunger, one of those weird plungery things. I think I got the lot, didn't I?
Well, you'll be delighted to find out that direct electrical stimulation of your brain appears to work. This morning, you remembered 11 items. This afternoon, 13 items.
I am clearly a genius, obviously. Charlie, thank you very much indeed. Can you just explain what's actually going on here?
When you learn, you change the strength of connections between the brain cells. And what we're doing here is putting a very small electric current into the frontal areas of the brain, which is where we know this kind of learning happens, to try and make that process a bit easier.
That electrical current gives a temporary boost to the connections inside Dallas's brain, increasing his ability to learn and remember.
I think that was absolutely astonishing. Now, although Dallas, you are just one sample and that does not make a scientific study, the original research from the States showed that electrical stimulation improved working memory by 10%. Now, I'm not sure that would tempt me to wear one of those things to a job interview or something like that. But nonetheless, I think, on average it's 10%. You seem to manage almost 20% more, Dallas.
And clearly I also look a lot better.
Good grief. The things we do for science, but time to get back to Jan now and his quest to boost our brain power. Jan, my lovely, have you got anything a bit better to help with Dallas's memory? Help me out.
Well, Liz, although most of the evidence is based on research in older people, there are some interesting things that apply whatever age you are. And we've been trying out one of the best things you can do. Keep going. You're looking like, you're definitely getting a good workout there.
I have no idea what this has got to do with brain training.
I don't see how this is going to affect my memory.
We're going to see if just 6 minutes hard exercise can increase our audience's memory.
Well, if it does increase my brain power, I might do it more often.
Obviously, I would join you, but there's no spare machines, so sorry. An experiment in 2007 showed that doing this improved learning speed by 20%, basically boosting memory. But what will it do for our studio audience?
2, 1, stop!
As a comparison, we also asked them to read some mind-expanding literature.
I'm reading Nature magazine to improve my brain, apparently.
We don't really know the effect it's going to have on us.
I'm just reading at the moment. It's supposed to be controlled reading where I'm not supposed to be talking. Oh.
We give everyone tests of their memory.
And start now.
Can exercise do more for them than mind-improving literature? The results are collected and analysed. And
we find that exercise seems to be boosting our volunteers here brain power significantly, and that's what other studies have found too.
in fact, our exerciser's memory improved by over 20% in our short-term studio test. And that's consistent with the science. But apparently exercise doesn't only give you a quick fix. Research last year showed that taking up moderate exercise for 6 months can improve memory over the longer term.
The brain is capable of surprising change. Stimulating it with music and electricity can enhance the way the connections work. But exercise does something even more extraordinary. It releases a chemical which increases connections long term.
Now, one of the reasons exercise is so good for you is because it releases a particular brain chemical called brain-derived neurotrophic factor, or BDNF to you and me. Now, take a look at this. Under here, I've actually got some brain cells that have been growing for 36 hours without any BDNF. And here is an identical sample with BDNF added. Let me focus on that so you can see.
Adding BDNF, which is released by the body when you exercise, stimulates the growth of connections between brain cells. Here's before and here's after.
Check out the number of connections, a huge increase in connections in those brain cells. Now, it's making connections like these that help you forge new memories, learn new skills, and find new ways of solving problems. I can't fight it any longer, can I? I've got to go to the gym.
Liz may be going to the gym, but we're off to the racetrack to exercise our brains in a very different way. Dallas and I have been training our brains with just one goal in mind: to control 2 London taxis by thought alone. Not only that, we'll be racing head to head.
Dallas and I are here at Santa Pod Raceway, where we're going to attempt to take motorsport to a whole new level. We're going to drive our brains to their limit with 2 races, speed and manoeuvrability. And the only way we will be able to get this to work is if we can produce clear and distinct enough thought patterns that the cars are under no doubt as to what we want them to do.
You think this is going to work?
I simply don't know.
This is a truly brain-busting operation. First, we're going back to basics, moving a cube on a computer screen by thinking clear, simple thoughts.
Push to go forward, and then pull to brake.
The cube software is then wired up to the remote control unit, using radio transmitters to control our driving robots, which in turn control our 2-ton taxis. What could possibly go wrong?
Okay, let's go, let's go, let's go.
It's time for the ultimate test. Can we focus our thoughts enough to successfully control these 2-ton beasts?
My mind is like a finely honed Jedi Knight.
Well, my mind is like a French philosopher. I think, therefore I accelerate.
But Dallas doesn't want to play fair.
I want you to think about Dr. Yan.
No.
In fishnets.
Never.
He's wearing fishnets.
He never would.
He's knocking at your door.
He wouldn't.
Will our brains be up to the challenge?
Go!
Yes, I've done it! The first ever brain-controlled taxi.
How come my car's not moving at all?
But my focus wanders. Dallas isn't even off the starting block.
Oh, that car! My car's rubbish!
Right!
It should be moving. I mean, on the computer it's moving. There must be something wrong with the car.
We rewire the system and start again. At last, Dallas focuses his brain and gets his taxi moving. Success. But he makes a classic schoolboy error. He takes his eye off the game.
I am your father!
In his excitement, he's lost his concentration.
Oh, you utter...
So I ramp up my neurons and take full advantage to close in on his tail. At last, after weeks of training, the power of my brain transformed into 2 litres of throbbing diesel. All those days of finally focusing the brain have paid off.
Oh, brake! Oh!
Almost.
Brainy enough to build a car, but clearly not to drive it. But what happened next?
With one cab down and determined to get my steering set, I took Dallas for a spin around the obstacle course.
Oh, we're off! Oh, Jeb, left! Okay, just knocked over a barrier. He's going the wrong way, we're going to hit wall! Oh. Okay, come on, Jem. Hope the meter's not running. Oh, we're off! Here we go, okay, watch out! Beautiful turning circle.
Oh, I'm going round and round.
Brilliant! Uh-oh, just back towards. Oh, a bit heavy on the brakes.
Should we say that we've almost mind-controlled a vehicle? We have, but I've just not learned to drive yet.
Moral of the story, never ever get into a cab with Jem or Dallas. Bless them.
It may have been a crazy idea, but it's an incredible achievement of mind over matter. A feat of engineering, problem solving, and training your brain to do something nature could never have imagined. Driving a London taxi by mind control.
I am your father!
The brain is capable of some truly incredible things.
It amazes me how my brain has readapted itself.
And it seems if we can enhance the connections between our brain cells, we can improve our brain's performance.
Amazing. Can I get a print out of this so I can show the boys?
Our huge scientific experiment may have shown that brain training games aren't the answer. But there are some simple things we can do to stimulate our brain's performance in the short term.
Very good.
And ways to improve our memory long term. Our brains are amazing, and understanding how they work can help each of us to realise our full potential.
A big thank you to our gorgeous audience for keeping us company and taking part.
And thanks as well to everyone at home that took part in this massive experiment.
Absolutely. Thank you very much. We'll see you soon. Good night.
Good night.
Goodbye.
Mr. Intelligence himself, Stephen Fry, bearing gifts on BBC Two in a moment in QI. Experts and their theories about life, the universe and everything. Get a comic going over on BBC 4.